All right, we'll see if we can get this done in one more video or if it's going to take 2 or whatever. Focus. Focus when I tell you to focus. Haha! All right, so we're going to practice solving some equations. So I've got the cosine of 2 theta plus 10 sine squared of theta equals 7. Okay, so I noticed that this is the odd one out. Okay, he's got a multiple of theta. I also know that this one with a single theta is in terms of sine. So if I can make this look like sines, then I'll be on my way to seeing what can happen. So I'm going to look at a double angle identity and notice that I can change that cosine squared into a, I'm sorry, not cosine squared, cosine 2 alpha, into a 1 minus 2 sine squared alpha. So this turns into a 1 minus 2 sine squared theta plus 10 sine squared theta is 7. And now it seems to be on my merry little way because I've got things I can put together. So 10 of these minus 2 of these is 8 of those sine squareds. And then I'm going to go ahead and subtract 1 from each side. So that's going to give me a 6. Divide both sides by 8 and reduce, and I'm going to get 3/4. And so now take a square root. Anytime that you are taking the square root during the process of solving an equation, do not forget your plus minus. So I'm going to end up with a positive or negative √3 over 2. So where does sine produce a positive or a negative √3 over 2? That is going to happen at pi over 3, at 2 pi over 3, at 4 pi over 3, and at 5 pi over 3. And those are the places where you get a positive or a negative √3 over 2. So let's try another one. We've got the cosine of 2 theta, and that's going to equal the cosine of theta. And I should have told you, I'm so sorry, our domain was restricted from 0 to 2 pi, and it's restricted again from 0 to 2 pi. Otherwise, I should have given you a general solution instead of just the 4 places that it occurs in one lap. So now I notice I've got multiples of theta here, but not here. So if I can get this thing to reduce to a single theta and stay in terms of cosine, that's what I want to do. So I'm going to look on back over here, and I notice that instead of cosine 2 theta, I can say 2 cosine squared theta minus 1. So this part is going to become 2 cosine squared theta minus 1 is cosine theta. And now I notice it's starting to look quadratic. I've got a squared term, a first degree term, and a 0 degree term. So I'm going to go ahead and bring this cosine over. So I've got 2 cosine squared thetas minus a cosine theta minus 1 is 0. And now I'm going to use substitution. So I'm going to say x equals cosine theta. And as usual, you do not have to write it that way. But sometimes people see it a little bit cleaner if it is written that way. We just have to remember to not forget to back substitute. So I'm going to use factoring by grouping here. And so working through that, we will find out that I've got a 2x squared, and then minus a 2x plus an x minus 1 is 0. So I'm going to pull a 2x out of the first two and get an x minus 1. Pull a 1 out of this one. Okay, I can't pull anything out that's common except for a positive 1. So now I've got x minus 1 times 2x plus 1 is 0. And now for my final thing, I'm going to take each factor and set it equal to 0. So I've got x minus 1 is 0, or 2x plus 1 is 0. So now we're going to go back in, and I'm going to substitute back in. So I'm going to add 1 to both sides, and then I'll know what cosine needs to be. So I changed my x back into a cosine, and I added 1 over. I'm going to subtract 1 and divide by 2. And then I'm going to replace my x with a cosine. And I'm doing all that because I'm running out of paper. All right, so where does cosine equal 1 on one lap of the unit circle? Not including at 2 pi. That's going to occur when theta is 0. Okay, where does cosine equal negative 1/2? Cosine will be negative in quadrants 2 and 3, and it will be negative 1/2 at 2 pi over 3 and at 4 pi over 3. Okay, so those are the places where you're going to have a negative ratio for cosine. So those are your answers. So let's try another one. Honestly, let's do 2 more. Okay, so I've got sine of 2 theta. I'm trying to do a representative sample. So the sine of 2 theta, and that's going to be minus the sine of 4 theta. And I need that to equal 0. Okay, so if that thing will equal 0 within 1 lap of the unit circle, so I'm going to go from 0 to 2 pi. And I notice first thing that my arguments don't match, but I am in terms of sine. So if I can get these things to all be in terms of 2 thetas and sines, that might help. So I'm going to leave this one as a sine 2 theta. And then I'm going to do addition, the sum of 2 angles on this one. So this is going to be a 2 theta plus a 2 theta is 0. So I'm going to use that sum identity to say I've got the sine of 2 angles being added together. So that's going to be sine alpha cosine beta, and then keep the sign. So this is positive here, it's positive there. So this one I'm going to rewrite. And then this entire part after the negative, watch out for your negative, is going to become sine alpha cosine beta plus cosine alpha. Oh no, sine beta. Oh my goodness, I'm out of room. Okay, so all of that together, I'm going to distribute this negative now. So I've got 2 terms in here. That one's squishy. Okay, and so both of those terms need to go negative. So I've got the sine of 2 theta minus the sine of 2 theta cosine 2 theta. And then this becomes minus. So I've got sine 2 theta cosine 2 theta. And all of this is supposed to equal 0. So I could have noticed it here, but I better notice it here that these are like terms. So I'm going to have sine 2 theta minus 2 of these things equals 0. And now I notice that I've got like terms again. Okay, I can factor out a sine 2 theta from here. So I'm going to factor out sine 2 theta, and that's going to leave me with 1 minus 2 cosine 2 theta is 0. So I don't have to try and force these things to work, because at this point I've got this factor times this factor is 0. So I should recognize that I can just set each factor equal to 0. So I'm going to take the sine of 2 theta is 0, and then 1 minus 2 cosine 2 theta needs to be 0. Well, for this one, I'm going to subtract 1 and then divide by negative 2. So cosine 2 theta will equal subtract 1, divide by negative 2 will be 1/2. So remember, we're within 1 lap of the unit circle. So for this one, I need to figure out all the places that sine will be 0. So where will sine be 0? Sine will be 0 at 0, and at pi, and at 2 pi, and at 3 pi, and so on and so on and so on. I don't care about the negative ones because I'm staying within 1 lap. But what do I have? I don't have a single theta. I've got a double theta. So this is going to be 2, and now I'm going to divide this whole I'm going to divide this whole chunk right here by 2. So 0 divided by 2 is 0. Pi divided by 2 is pi over 2. 2 pi divided by 2 is a pi. 3 pi divided by 2 is a 3 pi over 2. 2. Okay? And then you'll notice that this is quadrantal, 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 quadrantal. So the next one is going to be a 2 pi, which I don't want to include. Okay, so this is going to be my little list. So now I'm going to work on this one. So where does cosine have a positive ratio of 1/2? And cosine is positive in quadrants 1 and 4. And that's going to be at theta equaling, I'm not going to have enough room, at theta equaling pi over 3. And again, 5 pi over 3. So because I know I'm going to end up reducing, okay, I'm going to do some more iterations just like what I did up here. So what is a complete lap? A complete lap is going to be 6 pi's over 3. So a pi over 3 plus 6 pi's over 3 is 7 pi's over 3. So 5 pi's over 3 and 6 pi's over 3 is 11 pi's over 3. And let's just do one more iteration just in case. I've got 6 pi's over 3 plus 7 pi's over 3 is 13 pi's over 3. So what I'm doing is I'm doing this one and getting this and then adding another 6 pi. And then I'm doing this one and getting this and I'm adding another 6 pi. So that's going to be 17 pi's over 3. And it goes on and on and on and on. But I don't have theta. What do I have? I've got 2 theta. So I need to divide all of these by 2, which means my denominators are going to become 6's. Okay, so pi over 3 divided by 2 is the same thing as pi over 3 times 1/2. So all of these become 6's. So my theta, I'm going to keep this list going, becomes pi over 6. So I need to list him. 5 pi over 6. 7 pi over 6. 11 pi over 6. 13 pi's over 6. Stop. Everything else is bigger than 1 lap, so I don't need those. Those were extra. So all of these are your answer. Okay, so I think, I said I might do one more. I think you're good to go. So as usual, you can email me or send me an Ask My Instructor if you're stuck. But other than that, you are almost done with Chapter 8. One more section.